So in this lesson, we're going to do a little more work with word problems involving quadratic equations, and specifically we're going to look at word problems that involve consecutive integers. Okay, so let's first review consecutive integers. So consecutive integers, an example would be like the numbers 7, 8, 9. Okay, so we always let x equal the first consecutive integer. Okay, so to get from 7 to 8, we're just adding 1. So x plus 1 is going to represent the second consecutive integer. And then to get from 7 to 9, we're adding 2. So x plus 2 represents the third consecutive integer. Okay, next one is consecutive even integers. So that would be something like 2, 4, 6. Right, so again, we always let x equal the first consecutive even integer. So to get from 2 to 4, we're adding 2. So we're going to let x plus 2 equal the second consecutive even integer. And then to get from 2 to 6, we're adding 4. So we're going to let x plus 4 equal the third consecutive even integer. Okay, consecutive odd integers. Okay, so an example of consecutive odd integers would be like 3, 5, 7. So again, we always let x equal the first one. So x would be the first consecutive odd integer. So to get from 3 to 5, we're adding 2. So we would let x plus 2 equal the second consecutive odd integer. And then to get from 3 to 7, we're adding 4. So we would let x plus 4 equal the third consecutive odd integer. So when we're talking about consecutive even or consecutive odd, the let statements are always going to look the same. All right, so now let's try an example. The first example says the product of two consecutive odd integers is 99. Find the positive integers. Okay, so first they want us to find two consecutive odd integers. So we're going to need two let statements. Okay, so we always let x equal the first consecutive odd integer. And then again, since we're talking about consecutive odd, x plus 2 is going to represent the second one. Okay, so then it says that the product of the two consecutive odd integers is 99. So product means multiplication. So if I take x and x plus 2 and we multiply them, it equals 99. All right, so to solve this, we're going to distribute on the left. So we get x squared plus 2x is equal to 99. So it's a quadratic, so first step, I'm going to set it equal to 0. So I'm going to subtract 99 on both sides. And then we want to try to solve by factoring. So the first thing we look for is the GCF. Okay, so these three terms don't have a greatest common factor. All right, so now we're going to try our try to by method. We're going to go from a trinomial to two binomials. So we're looking for numbers that multiply to 99 and subtract to 2. All right, so again, we're going from a trinomial to two binomials. So the numbers that multiply to 99 and subtract to 2 are 11 and 9. Okay, so the signs are going to be different inside the parentheses, and the numbers have to combine to positive 2. So positive 11 and negative 9 combine to positive 2. So I'm going to make my t-chart, set each factor equal to 0. So we get x equals negative 11 and x equals positive 9. Okay, so again, quadratic always has two solutions. So in this question, it says find the positive integers. So if it's only asking for the positive integers, we're going to reject the negative. All right, so our first consecutive odd integer was 9. And then our second consecutive odd integer, 9 plus 2, is 11. Okay, and if I take the product, if I multiply those two numbers, 9 and 11, we do get 99. All right, let's try another one. So this one says the product of two consecutive integers is 56. So again, we're talking about two consecutive integers. So we're going to need two let statements. So we always let x equal the first consecutive integer, and then x plus 1 represents the second consecutive integer. Okay, so the product of the two integers is 56. So again, product is multiplication. So x times x plus 1 equals 56. Okay, so we're going to distribute. So we get x squared plus 1x equals 56. So I'm going to set my quadratic equal to 0. I'm going to subtract 56 on both sides. All right? And then we want to factor. So first thing we look for is a GCF, or greatest common factor. So these three terms do not have a GCF. So we're going to do try to by. So we're looking for numbers that multiply to 56 and subtract to 1. Okay, so we're going from a trinomial to two binomials. So numbers that multiply to 56 and subtract to 1 are going to be 8 and 7. So the signs in my parentheses are different. And since the numbers have to combine to positive 1, positive 8 and negative 7 combines to positive 1. So then we're going to set each factor equal to 0. All right, so this is where we make our t-chart. So we get x equals negative 8 and x equals positive 7. Okay, so here they asked us to find the negative integers. So in this case, since they want the negative integers, we're going to reject the positive. So the first consecutive integer is negative 8. And then if I add 1 to that, we get negative 7. Okay, so negative 8 times negative 7 does give us positive 56, because a negative times a negative is a positive. Okay, let's try one more. Okay, find two consecutive positive integers such that the square of the smaller increased by 4 times the larger is 64. Okay, so again, they want two consecutive positive integers. So we're going to need two let statements. So we're going to let x equal the first consecutive integer. And then we're going to let x plus 1 equal the second consecutive integer. Okay, so it says the square of the smaller, so the square of the smaller is going to be represented by x squared, increased by 4 times the larger. So increased we interpret as addition, and it's 4 times the larger. So I'm going to take x plus 1, and we're going to multiply it by 4, is 64. So equals 64. Okay, so to solve this, the first thing we want to do is distribute on the left-hand side. So we're going to get x squared plus 4x plus 4 is equal to 64. Okay, so it's a quadratic, so we're going to set it equal to 0. So we're going to subtract 64 on both sides. So we get x squared plus 4x minus 60 is equal to 0. Okay, so now we want to factor completely. So on the left-hand side, we don't have a greatest common factor. So here we're going to use try to by. So we're looking for numbers that multiply to 60 and subtract to 4. Okay, so we're going to do 2 sets of parentheses because we're going from a trinomial to 2 binomials. And the numbers that multiply to 60 and subtract to 4 are going to be 10 and 6. So again, signs are different. And here the larger number is going to be positive because positive 10 and negative 6 combine to positive 4. So then we're going to set each factor equal to 0. So we get x equals negative 10 and x equals positive 6. Okay, so again, in this problem, they only wanted the positive integers. So we're going to reject the negative and keep the positive. So our first consecutive integer was 6. And our second consecutive integer was 7. All right, so I hope this was helpful. I will be posting a practice worksheet for you guys to try some questions on your own with worked out solutions, and then there will be a Google form for you guys to fill out on this.